Good morning, students, and welcome to our live session. Today we are going to summarize on trigonometry. We have done trigonometry last week, and also we did some trigonometry on Tuesday. So today we're going to take this class and summarize the work that we have been doing on trigonometry. And I trust that you have been following what we have been doing, and you understand most of the concepts. Let me invite you, please don't be afraid. Send your comments. Let us know what you're thinking. Let us know how you're understanding the work, so that we could better provide for you. All right, my name is Mr. Patterson as usual, and hopefully we're going to have a wonderful class this morning. So just to summarize what we have been doing with trigonometry. Now, trigonometry, as we said, it speaks about triangles, and with triangles we have three sides and we have three angles. Now, there are different types of triangles. We looked at the right angle triangle, which is the triangle with a 90-degree angle inside of it. And with this right angle triangle, we looked at some nice tools that we can use to solve questions, to solve trigonometry questions. And one of the rules that we looked at, or one of the technique or method, is where we use a relationship between the angle and specific lengths on the triangle. So we have three nice trigonometric ratio here. And the sine of an angle is equal to opposite over hypotenuse. Cosine of an angle is equal to adjacent over hypotenuse, and tangent of an angle is equal to opposite over adjacent. If we were to do a small sketch of a right angle triangle, so we can appreciate what are we talking about here. Okay, so this is going to be our summary class on trigonometry. So given this triangle, it has a 90 degrees inside of it. And if we were to identify another angle inside of the triangle, apart from the 90 degree, let's assume that the angle is here. We said that the Greek word for this symbol is theta. And the sides on this right angle triangle have a specific name. All right? We identify that the longest side is called the hypotenuse side. That's what we call H. So H is the hypotenuse side, and the side which does not affect this given angle is called the opposite side. Another way of looking at this is we can say that this side, the opposite side, is the side that is opposite to the given angle inside of the triangle. So this is called our opposite. Let's just say OPP, and this is HYP. All right? And finally, the third side, which is the side that is used to create the angle along with the hypotenuse, this is called your adjacent side, ADJ. Okay? So a lot of work would have been done before, and this formula would have been created to find either to find the angle or to find the length for the opposite or the length for the hypotenuse. Okay? Because it uses all these three: angle, hypotenuse, and opposite. And you can reason what is happening with the cosine. Now, another formula that has been created when it has a right angle, when we have a right angle triangle, is this Pythagoras theorem here. Okay, now this Pythagoras theorem states that the length of the longest side squared is equal to the sum of the squares for the other two sides, which is the adjacent and the opposite. So we have 8 square equal to a square plus o square, and we can change to a square plus o square plus a square. Doesn't make a difference. The other thing we needed to learn is that with the area for a right angle triangle, we use half base times height. And quite easily, these two sides, the base and the height, they are always going to be either the adjacent and the opposite length. Because this 90 degree here is what gives us the base and the height. So the base goes across like that, the height goes up like that. And if you were to change the position of this triangle, this could be the base and this could be the height. But it doesn't make a difference, okay? Because we are multiplying, so we know we'll get the same result. So this is for right angle triangle. Now then we go to non-right angle triangles. So we have non-right angle triangles. And with non-right angle triangles, we had 3 types. We spoke about the isosceles triangle, the equilateral, the scalene triangle. And we have to know the properties for each of these types of triangle. All right? The equilateral is where we have 3 equal sides. 3 equal sides. Okay, so you have 3 equal sides, and that will also give us 3 equal angles. So we have 3 equal sides and 3 equal angles. Then we have the isosceles, which will give us 2 equal sides. So 2 equal sides and 2 equal angles. These are going to help you. These properties are going to help you when you need to solve multiple choice questions a lot of the times, and some long paper questions. And then the third type we said is the scalene triangle. Okay? And we have no equal side, no equal angle. Okay? Now what are the properties we need to use? What are the methods that we need to use to solve non-right angle triangles? Well, we summarize them to be using the cosine rule. So we have only a few. We have either the sine rule or the cosine rule. Let's quote the sine rule first. So we have the sine rule, which tells us that the side A in relation to the angle, sine of the angle for A, is going to be equal to the side B in relation to the sine of the angle for B. And we have the side C, which is also going to be equal in relation to sine of the angle for C. So this is our sine rule. And our cosine rule, okay, the cosine rule tells us that if we were to make one of these sides the subject of the equation, let's assume that we take this side A to be the subject of the equation and we square that side, it is going to equal to the sum of the squares for the other 2 sides, which would be B and C. So it would be B squared plus C squared. And then we subtract twice the values for B and C, so it will be twice B and C, with cosine of the angle for the length that you made the subject. So this will be cosine of A. All right? So these are the 2 formulas we use, either to find the length of a side on a non-right angle triangle or the value for an angle in a non-right angle triangle. The last thing we needed to know for these non-right angle triangles is how to find the area. So the area for a non-right angle triangle would be half times A times B times sin of C. And this wasn't too difficult for us to realize, because if you see what's happening here, class, half base times height. Now, this is a non-right angle triangle. So if we were to consider the base and the height to be A times B, well then this angle C is only going to be the angle between those 2 lengths that you use to find the area. If it was, well, because it is a non-right angle, there is not a 90 degrees, okay? So let's just draw an example of a non-right angle triangle, see what we get. So we are summarizing and we want everybody to follow what is happening so you have a better understanding of how to solve these questions. So this is a non-right angle triangle, okay? So here we have the angle A, the length that goes with A would be this side here, A. And if this is our angle B, the length that go with B, that corresponds with B, would be this side. And we use common letters for the length. C, then the length would be there. Okay? So that is for non-right angle triangle. Our last class on Tuesday, we introduced two more concepts. And Mr. Renson Humphrey would have done a good job with this one. And he spoke about what is called the angle of elevation. Okay? So the angle of elevation, this angle of elevation is quite simple. It is where we're going to create an angle with a horizontal line and another line projecting upwards. So the angle of elevation looks like this, the horizontal line and a line projecting upwards. So you're looking at something upwards with the horizontal line. So this is your angle of elevation, quite simple right there. The angle of depression. So the angle of depression, we are saying that this one would be where you have the horizontal line and you're producing an angle with another line projecting downwards. So this line goes downwards like that. So this is now your angle of depression. The last thing we mentioned is called a bearing. Now a bearing, we are saying is you have a north pole. So you have a north pole in which you are using that north pole to come up with an indication or an idea to represent a specific angle value. So we have a north pole, okay? And at this point, you only need now to draw another line to represent a specific angle value going in a clockwise direction. So you have a clockwise direction from this north pole here at the center this way, and you can use the other cardinal points to guide you in coming up with an accurate description of this particular angle that they want you to get. So you know for sure, if you have a bearing of 80 degrees, it must be in this quarter there. So the other line will go this way. For example, like that. This is your bearing of 80 degrees. If you need to get a bearing of 120 degrees, again, just start with the North Pole. Use these cardinal points here to give you direction. Here is 90. Here is also 90. So if they ask you to get a bearing of 120 degrees, you know for sure you will be in this second quadrant, this piece of the quadrant there. Okay? Because that's 90, it will look somewhere like that. So this would be your bearing of 120 degrees. So this is basically the overview of what you're doing with trigonometry. Okay? And if you have a good understanding of each of these, any question come on trigonometry, you should be able to do well. Now, I am going to go through the questions that we would have started to look at on Tuesday. And then, as we progress, we will touch, hopefully, on all of these skills in trigonometry in different parts of the question. Okay? Because most of the questions, they don't touch one skill and one skill only. There is a part that needs to use maybe these rules, sine rule and cosine rule, and there is another part that maybe uses these angles of elevation and angles of depression. So you need to have a good understanding of each of the different components. Okay? So, I'm going to erase the board. Please don't forget the formulas. And if you do forget the formulas, no problem, because the formula sheet gives you all details of more than 90% of the formulas that you will be using on the exam. Okay? So, On your screen, you will see projected this question. And this was taken from a past paper as well. And we started looking at this in our last video, so we're going to finish it today. The question reads, the diagram below, not drawn to scale, shows the position of two hurricane tracking stations, P and Q, relative to the point O. So we have this diagram, and this is a sketchwalk. We don't necessarily need to draw a perfect diagram. We just need to have a fairly accurate diagram to represent the information. Okay? So this is our P point, and we have this N, North Pole, O, and we have Q here. So we have Q. Okay, sometimes I like to draw the diagrams because it gives you a good feel of, the question. When you draw it, right away you can actually get a good sense of what is happening in the question. Now, so let's use this as a representation of the diagram. Because it's not drawn to scale, so it's okay. Now, there are two tracking stations that we have. And they're telling us that P is on a bearing of 25 degrees from O. So that is very important. P on a bearing 25 degrees from O. P is on a bearing 25 degrees from O. So if you were to put in this 25 degrees, you can appreciate that 25 degrees from O will just start from the North Pole, because we already stated that these bearings must start from the North Pole. So 25 degrees from O will come from the North Pole, and it will be like that. So this is 25 degrees. So for one mark in your question, you only need to insert that 25 degrees. Okay? And if you continue reading, it will tell you that OP is 400 kilometers. So the length of OP is 400 kilometers. So you only need to put 400 there. Again, that's going to give you easy mark for the question. Continue reading. They tell us that Q is on a bearing 80 degrees from P. Let's write that down. So Q is on a bearing 80 degrees from P. Very, very important concepts. We need to learn these. Okay, read your question carefully, okay? So Q from P. So we are now moving from P. Identify where you're moving from. We're moving from P to Q. So from P to Q, we are going to get a bearing of 80 degrees. And again, you need to just get your angle coming from the North Pole. So this is going to be 80 degrees. And no one is going to get confused if I put 80 degrees or 080. Okay, because we understand that 25 degrees can be written like this or like that. Our last part of the information, they're telling us that the distance from P to Q is 700 kilometers. So P to Q is 700 kilometers. P to Q, 700 kilometers. Let's just put that in there. And I think I need to adjust my diagram a bit because we want to be realistic. Because the distance from P to Q is 700 and from O to P is 400. So this one should be a bit longer, which is okay still. Okay, so it should look something like that. Okay.
This is a 1 in a million jackpot. 1 in a million.
By His stripes we are healed. By His nail-pierced hands we are free. By His blood we're washed clean. Now we have the victory.
This is a 1 in a million jackpot. 1 in a million jackpot. So on Friday, May 15th, you can be a millionaire with a lotto jackpot of $1,320,000. You can make your dreams a reality. A new home, car, or that college education.
Lotto, you have to be in it to win it.
Next Lotto jackpot, $1,320,000.
Let your heart not be troubled, okay? Take your time again. Go back to the basic stuff. What do we know about these cardinal points? Every quadrant is what? 90 degrees. So we have, that's our point P here. We have north, east, south, and west. So from north straight to east, we have 90 degrees. So 90 degrees is here. Okay? We can appreciate that if up here only give us 80 degrees, then there is a 10 degree in between here that is missing to give us the direct east movement from P. Everybody appreciate that? So the direct east movement from P, we have 10 degrees missing. Let's just put that in. Let's just put that in there. So this is 10 degrees there, because 80 and 10 gives 90. And then here, we have a complete 90 degrees. We know it's complete 90 because this is our south coming down there. So from east to south, we have another 90. So this would be 90 inside there. Now, if you take all of this, it will give us now the angle for P. Everybody understands? That is one of the challenge that you need to go back and use these Z rules, the alternate angles, to find out which angles are equal. So if we take the sum of these, we have 25 plus 90 plus 10, which gives us a total of 125 degrees. So that angle at P is 125 degrees. Now there are other ways you might have been able to get that value, okay? If you see one, maybe you can send suggestion and let us know what you came up with to get the particular angle value for P. So this is quite simple. We already finished with that one. Now let's go to part B. So part B, they want us now to calculate the length of OQ. So we need to find the length of OQ. So we need to find the length of OQ. Now OQ would be this particular side here. And we appreciate that this shape, it's a non-right angle shape. It's now a non-right angle triangle. So if we take it out to a sketch, right? If we do a sketch of the diagram, we have 400 here, 700 there. We have 125 inside here. We need to find the value for this N, O to Q. Not going to be a problem because it's non-right angle. We know we need to go to use our sine rule or our cosine rule. And we establish a nice way of determining which of the rules would be able to use. Because in this question, we need to find the value for this side, X. We have this side, we have this side. So we have 1, 2, 3 sides in the question. All right? And we have an angle. So if we use the sine rule, we'll see that we're going to have more than one unknowns to find. Because there is not a complete, ratio with the length and the angle for the length. Look, X over sine 125. We don't have an angle there to go with sine 400. We don't have an angle here to go with sine 700. So the only rule possible would be the cosine rule. So the cosine rule, we're saying we're taking this to make it the subject. So x squared equals to 400 squared plus 700 squared minus 2 bracket 400, 700 cosine of 125. Okay? We would have already looked at how to simplify this in stages, but with my calculator, I'm going to shorten some of the steps, okay? I will add these two first. I will multiply here, and then I will put the cosine of 125. Okay, so you can follow or you can try. Ready? Okay. So let's see what's happening. Okay, so just to make sure that you have your scientific calculator. So x squared, 400 squared plus 700 squared. Let's just put that in. 400 squared plus 700 squared equals, that gives me 650,123. Good? Then I'm going to subtract 2 times 400 times 700. Okay, remember these are multiplying. So that gives me 560,123 cosine 120. Okay? Now, this particular calculator uses 1/24 then cos. This particular calculator. Some calculators will punch in cos 120 and it will give you the solution. But this one is the reverse. So I'm going to have to punch in 1/24 cosine equals, then I will multiply it by 560,000. Good? So let's follow what is happening. So I get 120 cos. Okay? Then I'm going to now multiply that by 560,000 equals. So it gives me this as my answer. Okay? So this is 650,123 minus comes here. Now appreciate, class, that when I multiplied, I got a minus result of minus 280,000. Okay? Now, I'm going to simplify here. Minus and minus will meet with each other, so I'm going to end up with a positive. Okay? So this will just give me 650,000 plus 280,000. So I can just simply, well, I'm going to change that to a positive. So I can erase that. Let's do it over. 650,000 plus 280,123 equals 930,000. Good? So this is all x squared. Now if you had the other calculators, it might have been easier for you to just punch it in straight like that. Okay? But nonetheless, we're going to get to the solution. Now we need to find x, which means the square comes over and it becomes the root of this 930,000. Which simply tells us here that x, so I will have to punch in the number for us again. So it will be 930, 1, 2, 3 zeros. Then I take the root of that and I get my value of 968.37. So this would be 968.37. I round it off, okay? Kilometers, because this was given to us in kilometers. Sorry, my mistake, class. Thank you very much. Someone did correct me there. So it's 964, my mistake. So 964.37 kilometers. Well, that's a good observation. Well done. Okay, so we have finished with the second part of the question. If you want, if you have the regular calculator that operates by putting in cos force, you can punch everything all together, then press equal, it will give you this one. Okay? And then you take the square root of that particular result. I'm going to try it again just to double check my work to make sure that I'm good. Put the same value. Okay, now, so given that this part is solved, now let's go to part C to see if we can get a nice solution for part C. Okay, now for part C, they want us to find the bearing of Q from O. So we are moving from O to get to Q. Important, you always need to know where you're moving from. So we're moving from O to get to Q. Let's speed up a little bit. So if we're moving from O to get to Q, it means that we want to take care of all of this movement from the North Pole to this line that generates the movement going to Q. We already know that this angle here is 25. So our next challenge is to find out what is this angle inside there. Okay? So if you want to get this angle inside here, you can appreciate that you already found the length for O to Q, which is 964. So you can put that here, 964.37. So you already have this length, you have this angle for the length. So we have a match the angle with the length. And now we need to find the value for this angle, but we also have the length for this angle. So straight away, you can use your sine rule to solve for this. Likewise, you could have used your cosine rule. Your cosine rule could have also been used to solve that because you have 1, 2, 3 sides. You have the 3 sides to work with, and you have the angle inside there to match with one of the sides. Okay, so we would have to, we could have used the cosine rule. I think we could have used it. We could have used it. Because this angle goes with this length. So that was my mistake a while ago. This angle goes with this length. So we can make this line and this line the right part of the equation. Let 700 be over on the left side. So we get 700 square equals to square plus 964.37 square minus 2 bracket 400, 964.37 cosine, continuing cosine of this angle. So we could have used this formula, or we could also use the sine rule, because we have the angle. To find the angle, and we are given a specific length. So, if we use the sine rule, remember with the sine rule, you must put the length 700 over sine of this angle, which equals to this length 964.37 over sine of this angle, which we found to be 125. So any of these formulas could have been used to solve for this angle inside here. Okay, which one you think is best for you, you use it. Okay, just that we understand. And I will use this one because this one looks a little bit more simpler. So I will use the sine rule there. Let's apply the sine rule, see what we get. So if we are solving with the sine rule, because we want to find the value for this angle, we can simply put this term on top and put this 700 below. So we invert this fraction, and we also need to invert this fraction here. That's a simple method. We can try it. So we get sine of the angle over 700 equals to sine 125 over 964.37. Okay? It might take a little bit of effort, but nonetheless we can get to the end. So now we need to get this as your subject. So this 700 needs to move over on the other side. And from a divide, it goes over to multiply. So we get sine of the angle equals to 700 sine 125 all divided by 964.37. Okay? Take control of what you're doing, class. Don't be too bothered about, how the appearance of it. Because all we're doing is we're transposing from divide to multiply because we want to make sine the subject. Now, we need to get this angle to be separated by itself. So, SIN goes over and it becomes the inverse when it goes on the other side. So the angle is equal to sine inverse, and I can do all of this at once. Sine inverse 700 sine 125 all divided by 964.37. Okay, so this is where your calculator is going to help you with this now. Remember, for me, in my calculator, I need to put in the number first and then sign after. Okay? So I will have to simplify this first and then press sine inverse of whatever result I get inside here. All right, so let's just walk this as it is. Okay? And you can see how useful it is when you get a very proper calculator to solve these problems, because your calculator can ease your workload. So let's go through it. So 125 sine, because mine uses the number for us. Then I will have to multiply this by 700 equals 573.406 and other numbers. Then I will take this result and divide it by 964.37. So I get this as my answer. So now my angle is equal to sine inverse of 0.5945917 and 5. Okay, 594591735. Now let's see if I can keep this as it is. I'm going to keep this as it is because remember my calculator uses number first. Then now I'm going to get that sine inverse. So I go shift sine inverse of that number that was on the screen in my calculator. So my angle is equal to 36.48 degrees. Okay, so your angle is equal to 36.48 degrees. Let me give you a small challenge, and our next questions we will work a bit faster, okay? So the challenge is for you to use this formula and tell me if you end up with the same value that you have here. Okay, that would be your challenge. I give you 1 minute to use this formula and tell me if you end up with the same angle as 36.48. So 1 minute on the clock. Good class. So I trust that you tried to use the cosine rule and you end up with the same value for the angle of 36.4 degrees. Now let us go through about one or two more questions and see if we can apply what we have learned so far with the trigonometry. So on your screen you will see the second question, and they get easier as you go along, okay? So the second question shows, again, a non-right angle triangle. So we have a non-right angle triangle, and they are telling us that there are three stations, P, the movements of the cardinal point, such that the bearing of Q from R, so the bearing of Q from R, I like to highlight where it say from, okay? Of Q from R. So the bearing of Q from R, it's coming from R. So we're going from R down to Q. That bearing is 116 degrees, and they give us that in the diagram. So this is 116 degrees. Already some things are lighting up in your head, because you know if this is your 90-degree part, then this angle would be easily solved by taking away 90 from this 116. All right? So let's continue and see what else we get in the question. They are telling us that the bearing of P from R, one more, bearing of P from R. So the bearing of P from R, again, from is important there, from R. So from R, we are going all the way around to come back to the line for P. So the line that gives us P. So this bearing here, remember it has to be in a clockwise direction. This bearing they are telling us now is 242 degrees. Okay? If you go through the question, the first question is asking us to show that the angle PRQ is actually 126 degrees. So the angle PRQ is actually 126 degrees. And even if you don't understand what is happening here, the fact that they give you these two angles, you can simply see that if you take one and subtract the other, you're going to get the required angle value that is there. So it should not be too difficult. Okay, this is quite easy. You just say that this angle, PRQ, and make sure to understand where is PRQ, okay? PRQ is going to give us this angle value inside there. This angle value is what we want to find inside here. That's the angle value we want to find. So PRQ would be 242 degrees. Okay? 242 minus 116, which gives us, without a doubt, 126 degrees. Okay, so that's quite straightforward. Then the next part of the question asks us now to calculate the distance of PQ, given that the line from P to R is 38. P to R is 38 meters, and the line Q to R is 102 meters. Again, you appreciate this is a non-right angle triangle. It's a non-right angle triangle, we only know that the value inside here is 126 degrees. Okay? So in order for us to find the length of this side, PQ, we go and do our check. If we were to use the sine rule, we must have angle corresponding to length. This angle corresponds to this length that we need to find. But we don't have another angle corresponding with a particular length. So we are going to end up with more than one unknown in that equation. So the only equation we can use is our cosine rule. And again, the cosine rule, you can quote it. This side, if we make it the subject, this side squared equals to the other two sides squared, the sum of the other two sides squared. So x squared equals to 102 squared plus 38 squared minus 2 bracket 102 bracket 38 cosine of 126 degrees. Okay? So you work this out, you get the specific values. Calculator. So let's work it out, class. This time I'm going to walk this way. Okay, remember we have different ways of solving it. So I'm going to walk this way. Okay? Now, if I take 126 because of my calculator, so I take 126 cos. Then I'm going to multiply that result by 38, multiply by 102, multiply by minus 2. Okay? Then I'm going to add 102 squared plus 38 squared. Understand? Because of my calculator. Now, so let's see what happens. So 126 cos. I get that as my result. Then I'm going to multiply this by 38. I'm going to also multiply by 102. Then I'm going to multiply by minus 2. Let me see where my minus button is. Okay, let's just multiply by 2 equals, so we have this figure here. Now I'm going to have to, I can multiply by minus 1 to get this to be a positive figure. Okay, but I'm going to just simply change this to a positive because I'm not too certain about this minus sign here. Okay, so I'm going to write this down in my memory. So this will be 4, 5, 5, 6, 5, 1, 1, 2, 7, 6. Okay, 4, 5, 5, 6.5, 1, 1, 2, 7, 6. Let's just put that back in. And remember, it will change to a positive, okay? So we get 4, 5, 5, 6.5, 1, 1, 2, 7, 6. So that is me changing it to positive there. I'm going to now add 38 squared. So 30, plus 38 squared equals to that. Now I'm going to add as well plus 102 squared equals to that. So this x squared is equal to 16404.51128. Okay? Make sure you have that when you did the other way around. So I give you 5 seconds to confirm this is the correct answer that you got. Good? So if you did it straight away, you would have get back the same value. Good? Now x would be equal to the root of whatever you have here. So it will be 16404.51128, and you could have keep that number in your calculator. So you keep that number in your calculator, and you're going to get the square root of that number. So x now equals to 128.08 meters. Okay? Let's calculate that boy. Okay, so that's good. I am happy that you have followed through on what is happening here, class. I know that the numbers seem to be a bit big, but I promise you, if you have one of those sharp calculators that you punch it straight across and press equal, it gives you the value, it will be much easier for you. Just understand the concepts, okay? The approach that we're taking. The calculation part of it, you let your calculator help you with that. Now, let's go to the third question, and then I will give you some time to get some refreshment, and then we'll wrap up our class today. So the third question is where we are looking at the position for 3 points on a horizontal plane. So we have P, Q, and R. You can see it on your screen there, the question. So this is our third question. So we have 3 points on a horizontal plane, PQ and R. Now PQ is 120 kilometers, and QR is 150 kilometers. Okay? And then P going to R is 150 kilometers. Sorry, we don't have Q to R. So we have PQ, 120 kilometers, and we have P to R to be 150 kilometers. All right? Then now they're telling us here that this angle is 23 degrees at P. Good? And I did not put in the bearing, the cardinal, the North Pole for the bearing, because usually sometimes these things are distractors. You don't really need to use them all the time for each part of the questions. All right? Some parts you will use the bearing, some parts you don't use the bearing. But we can appreciate that if we were to solve for 3 marks for the length of Q to R, if you are solving for the length Q to R, then this angle goes with this length. So if you give that the side X, all right, you give that the side X, you can use now the cosine rule to help you to solve for this length, because you have 1, 2, 3 lengths in the question, and you have an angle for one of the length that you need to find. Okay, so if you make this the subject, x squared equals to 150 square plus 120 square minus 2 bracket 150, 120 cosine of 23 degrees. So this is going to be quite simple for you to solve it. Okay? I trust that you can do that. Now, permit me not to simplify this to give you the answer. I leave it up to you to go and solve and work for it. Okay? At the end of the question, I will come and give you the solution to ensure that your answer corresponds to what I have. Okay? So that will be the first part of the question. Yes. Welcome back, students. So now I'm going to give you the solutions just to confirm so that you can check to see what you have. So for the value of x in question I, x is equal to 61.33 kilometers. Okay? For the second part, for the area of the triangle, the area into one decimal point is 3516.6 kilometers square. I round it off to one decimal place. And for the bearing of R from P, we can appreciate here that at this point, it's 180 degrees here. Okay? And if the entire bearing was 252, then I take 252, subtract 180. We're going to end up with a bearing of 72 degrees, right? An angle of 72 degrees, not a bearing. Okay? So this angle here would be 72 degrees inside there. And that angle is the same size as this angle, which is 72 degrees here. So this bearing that we need to find from P to R, so the bearing from P to R is simply 72 degrees plus 23 degrees, which gives us 95 degrees. Okay? So I trust that that's not going to be too difficult for you. So that's 95 degrees. I hope you can see the color of the chalk. The marker, sorry. So the bearing is 95 degrees. I hope that the questions we did today would have given you some, better idea of how to solve these trigonometry questions. All right. As usual, I'm going to give you some homework exercise for the weekend because today is Thursday and you have Friday, Saturday, Sunday, Monday, and we'll be back with you on Tuesday. So the homework would be presented to you on the slides, and I will simply go through them with you. So this question, you will try to solve it, okay? It said that the diagram not drawn to scale shows the position of the points A, B, and C on a horizontal plane. It gives you the length for the three sides, and then it asks you to calculate the size for angle ABC, the angle at B, and it also asks you to calculate the area of the triangle ABC. So go and look at what we would have done before. Some of the questions are quite similar. You take the same approach or similar approach and you should be able to solve these questions. And on the second slide, there is another set of questions that you can try out. In no random order, they will use either the cosine rule or the sine rule to solve them, okay? So you need to solve for the letter label given in the question, all right? So you have a different, you have 1, 2, 3, 4, 8 questions, and you either need to solve for the length of a side or you need to solve for the value of an angle. So try them out, and hopefully our next class I will give you the solutions for these before we continue. Next week, look forward to see Mr. Boswit, and we will be doing consumer arithmetic. So for those of you who are weak in consumer arithmetic skills, you will get some good update on how to solve those kind of problems. So again, thank you for being with me today. I know today would have been long and enduring, but nonetheless, we made it to the end. And see you next week. Have a great weekend. Bye.